What is the meaning of life?
The meaning of life is subjective and can vary from person to person.
So what you just saw was a demonstration of this ESP-32 ChatGPT AI assistant I kind of built, inspired by Jarvis from Iron Man. I really always wanted to have like an AI assistant, a little AI companion, a buddy to talk with and ask really complicated questions and get instantaneous response. As you saw from the video, there's roughly 10 to 15-second delay, and we're going to go into why that is, and we're going to go into how I can go about solving this. But yeah, we have it right here. This it's basically two ESP32s. We have this digital analog converter, a DAC converter. So then we also have this microphone, and the digital analog converter is connected to a speaker, which outputs everything. And we're gonna go into how this works. We're gonna go into why this is such a complicated project to build, why it took me as long as it took me, and why there's such a long delay, and how we can go about potentially fixing this. And so the first thing we have to consider is all of the input outputs, all of the post requests and the requests that are going through, right? That are transpiring. So first we have an ESP32, right? Let's go here. We have an ESP32 1. So we're gonna call this one ESP32 1, right? This is our first ESP32, and that's getting sent. It's sending data to a Node JS server, and that Node.js server is running on my computer. So we're having an ESP32 pick up information from the mic, sending it to a Node.js server, which is then sending it to a Google API, right? The Google speech to text, Google speech to text API, right? SCT speech to text, and then it's sending that. It's taking that information. So we're sending a request to from the Node.js, so from the ESP32 to my computer. From my computer, Google speech to text API. From the Google speech to text API back to my computer, back to the Node.js server. We're just gonna call this like an NJ server. From there, from the Node.js server, is getting sent back to the ESP32, and we're going to call this the first ESP32, ESP32-1, the one indicating which ESP32. So from there, we're taking this information, and over the UART line, so the UART line, we have it connected. So we have a TX2 and RX2 connected together to send that data over the UART line. So we're sending that data from ESP32-1 over the UART line to ESP32-2, the second ESP32, right? From there, we're sending this data, so the information that I said, let's say I said, what is the meaning of life? From my mic, Node.js server, Google speech to text, Node.js server, ESP32-1, ESP32-2. So now where we are is we have just the text. What is the meaning of life? It took us this far to just get the text. What is the meaning of life? That's how long it took us to get just this simple string. So once we have the string, we're going to send it to the GPT API. And this GPT API in particular is programmed to have kind of similar personality to Jarvis, I guess if you can say personality, to kind of give responses like Jarvis would from Iron Man. Sends the GPT API. GPT API sends the post request back to ESP32 2. My apologies. We're gonna erase that. Dash 2. ESP32 2. From there, from ESP32 2, we're sending it to the Google text speech API, right? Thankfully, my computer doesn't have to process any of this data. So, by the way, all this is wireless. Whatever my computer is doing is over a server, over the network. So, for example, from the Node.js server, the ESP32 is sending that data over the network onto a specific IP that I gave it to send that data to my computer, which is running this server. That server can be run over like any service provider, any I'm sure, like I'm pretty sure Google has one that you can run for pretty cheap, which I might end up doing in the future. So from the ESP32, it sends us to now text to speech API. That again is by Google. So from the text to speech API, it sends it back to ESP32 2, And then from there, it finally outputs through the speaker. So if we look at what's happening, there's a lot going on, and there's a lot of inputs, a lot of outputs, a lot of requests and post requests being processed. And each individual post request and request, the whole kind of deal, might only take a second or two. Like individually, Google's very good at their job, and ChatGPT, they're really good with their APIs, and these ESP32s, they work pretty quick. They're dual core. I did actually still have to use two to make everything work. If you tried to have all these requests running on just one ESP32, um, it would not work. There would be too much data processing, and these guys can't handle that. They're pretty good, not that good. And so what's happening now is we're having a lot of like 1 second, 2 second transactions building up, and that gives us a total output of like 10 to 15 seconds from input output delay. So how do we make this better? The first thing I can think of is to get rid of that UART transaction. I think that's a minimal delay, but it's still something worth getting rid of. All of these delays are minimal. So ultimately, there's no one thing that's really keeping this up. I think the biggest thing would by far be the Node.js server streaming the microphone data to my computer and then to the Google speech to text API. So if we can eliminate that and have it all be directly from the ESP32 straight to the Google speech to text API, there is no Node MCU library or APIs specifically built for the Node MCU. I was thinking about building my own to have that function work, and that would be something that I would have to look into and get started on if we want to eliminate that factor of delay. And the other thing would be to, yeah, so combine the ESP32 and also combine some of the API transactions. So for example, uh, if we can get the Google speech to text, that data, to not directly send it to the ESP32, then send it to the ESP32, then to the GPT API, but take that data and send it directly to the GPT API, that would save us quite a lot of time. That would save us two, maybe three no, it would save us two transactions. That would save us two request post requests. So that's going to save us a good amount of time. Between those two things, I think this could be a pretty functional project and something that could be really good. So those two things are what I'm working on for this project right now. I obviously have other projects that I'm working on and school as well. But as soon as I get that done, which might take a while, I will definitely upload it to the website and update the website, update the repository. And yeah, that's it for this project. Thank you for watching. If you have any questions about how to go about building this, um, please contact me, and all of the information is also on the website, the code, and everything you need. So yeah, that's all for this one. Thank you for watching.